So what is an op-amp? An op-amp stands for operational amplifier. The op for operation means you can do multiple operations with a single op-amp schematic symbol right here for an op-amp. Maybe you want to invert a signal. Maybe you want to take an input signal and multiply it by some number. Maybe you want to sum multiple voltages together. Maybe you want to buffer the input voltage to another location on the output. The amplifier part, amp, means to increase the amplitude by a given factor. So the ratio between an output to an input is called the gain. So what am I talking about here? So let's say we take this multiplying example first. If we had a 1 volt input and I wanted to get a 3 volt output, that would be amplifying the input signal by a gain of 3, because I would multiply 1 times 3 to get my 3 volt output. However, this is also non-inverting is the terminology we're going to be used, because you can invert things as well using op-amps. Let's say I had a positive 5 volts and I wanted to get a negative 5 volts on the output. Well, you could do that with an op-amp. You could invert the input voltage to get a negative output voltage. Similarly, if you had a negative input voltage, you could get a positive output voltage. You can also combine different applications here. Maybe I wanted to invert and multiply. You can do that if you set up an op-amp as an inverting amplifier. In that case, if we took our example here, if I had a positive 5 volts on the input, and let's say I had a gain of 3 and I wanted to invert it also. So technically the gain would be a negative 3. But continue with this example. You would have a positive 5 volt input, multiply it by 3, and get an inverted output. So that'd be negative 15 volts instead. So it is a building block. You can use multiple op-amp configurations to create more complicated circuits. So here's the schematic symbol for what an op-amp is itself. You would have a non-inverting input and an inverting input. You'd have a positive voltage supply and a negative voltage supply pin. And then you'd have an output voltage. So let's say I wanted to let's say I wanted to multiply and get that 1 volt in and get 3 volts out. You would take your op-amp, which is this thing, and then set it up with resistors, capacitors, and other passive components to create the type of application that you need. So there's different ways to set up an op-amp to get your desired operation or desired amplifier. So let's say I set up my op-amp to get a gain of, instead of 3, let's say it was 400. Usually the gain is specified by ratios between resistor components and capacitor components. You can get different types of applications down here depending on how you set up an op-amp. So if you set up an op-amp and you calculate the gain should be 400. If you have an input voltage of 1 volt, you should theoretically get an output voltage of about 400 volts. However, that's probably not going to happen because you have a positive voltage supply and a negative voltage supply. These are usually looked at as the maximum output voltage and minimum output voltage of your amplifier circuit. So if I had a positive rail, is another terminology, of 5 volts, and a negative rail of negative 5 volts, that means that the maximum output signal I could create using this amplifier circuit, it can only go up to 5 and down to 5 volts. So you can get a maximum of like a 10 volt peak-to-peak signal output of your op-amp, even though your gain is 400. So theoretically, you would have an input voltage of 1 times a gain of 400 to get an output voltage of 400, but because you have a maximum rail voltage of positive 5 and negative 5, the terminology would be hitting the rails, clipping the output voltage, or in a more obvious sense, you don't have enough voltage to recreate the signal that is being asked to do. You don't have enough power. So They would be also called like the ceiling. And another terminology in the audio world would be called headroom of your amplifier. You do not have enough voltage to accurately recreate the amplified signal. So that is a key component, one of many different types of characteristics that an op-amp can do, such as amplification, like we talked about. Maybe we want to create a differentiator where it will have a positive output voltage whenever it sees a rate of change input. You can also do the same to create an integral or an integrator component for analog computing. It can be used for low pass, high pass, any type of filter that you want to create. You can use op amps, set it up with resistors and capacitors to create filters. You can use op amps for peak detectors. Maybe you have something going on and there's a large transient waveform input. Then whenever you see that large input, you want to say, hey, give me a high voltage output. There's also use in power applications for voltage regulators. Maybe you have 12 volts input, maybe you have 15 volts input. I only want 9 on the output. So you can use an op amp to fix the output voltage for your circuit to a specific voltage. Using analog to digital or digital to analog circuits as well. Maybe I have some varying voltage here and I want to understand it and sample it into a digital computer. So I need an analog to digital converter. Or the opposite way, maybe I have a computer that has a digital representation of an analog signal and I want to recreate that voltage information on the output. So that would be a digital to analog converter as well. Maybe I was talking about before with this positive voltage supply here and the negative voltage supply. You can create a clipper circuit where or this is another term called saturation as well, where the input voltage is so large that it will hit the maximum and minimum output voltages and then clip off the top and bottom parts of the waveform. And you can get this sort of relationship as well. You can also see the same thing in mixers. If I have 3 different op amps in a row and they're all sending different voltages output, I can sum them all together to a single voltage output line. That would also be used for adding. You can also use it for subtracting, take the difference between plus and minus to get some output as well, and more. There's so many different applications that you can use op amps for. So this is just an introduction for what is an op amp and what they're used for.